Hello everyone. A very warm good morning to everyone. Hope you all had a very nice, refreshing coffee session out there. I'm Yuvraj. I'm a part of Gen AI team at Zomato, and I'll be talking today about scaling customer delight at Zomato using AI with the power of AI. So before starting, I'd like to set up some context here. So we bifurcate the world of support in Zomato's universe in two different phases. One is pre-delivery, and the other one is post-delivery. So by pre-delivery, what I mean is once you place an order on Zomato, until the time it gets delivered, you are in the pre-delivery scope of the support. And once it gets delivered, you are in the post-delivery scope. So what kind of support issues come under the pre-delivery scope? You can ask the support, where is your order, right? You want to cancel your order due to some reason. You want to modify the delivery location of your order, things like that. But once your order gets delivered, you want to, maybe ask issues like, oh, your order did not really get delivered maybe, or your order has some spillage issue or some quality issue that you want to raise. So this is the post-delivery paradigm. So we'll be largely talking about pre-delivery here, right? With this, let's move on. So before AI came into picture, this was the support universe at Zomato. You can go through these screenshots. So in the first one, you must have seen these screens, right? All of you are aware of these screens, right? So in the first screenshot, you can see that the customer tapped "Where is my order" option, and the bot quickly escalated to a human agent here, right? In the second screenshot, you can see the customer in the last message, the customer finally wanted to order different items. But he or she had to go through a fixed set of options defined by us in order to get to that node, basically, right? So you can kind of imagine what kind of problems they were existing before AI came into picture. So first of all, as you could see, the experience that was offered by the bot is very transactional, in the sense that you need to go back and forth and traverse the tree that we designed for you. Though we designed that tree very carefully for you based on data, but that does not always fit all the kind of requirements. That is simply because the intelligence and the intent understanding was lacking before. So I had to create some set of nodes using data, and all customers have to use it. So it's a scripted support in that sense. Thirdly, as you saw in the first screenshot, the escalation was not very smart. So if the customer has tapped the node, "Where is my order?" I could have very well answered that, "Here is your order," rather than directing the query to the customer support executive, right? So with these challenges and AI coming into picture, what are some of the requirements, or what the new paradigm should look like with AI into picture? First of all, you all have chatted with ChatGPT. Everyone loves doing that. So the first requirement is that the bot should be conversational. The solution that we design should be conversational. It should not be transactional. You should just go there and type out your concern and leave it on us, right? Secondly, it should have a very deep intent understanding. Not that you traverse 3 nodes according to us and then you move on to telling us that you want to order different items. Just go there and type it. We'll do it for you. Thirdly, you want to take some action smartly. So what I mean by actions here is that probably you want to add some cooking instructions. You want to send some cooking instructions you want for your order to the restaurant. You want to add some delivery instructions for the delivery partner, or you probably want to cancel the order, sadly. So these are some of the actions that we want to decipher from your intent and messages rather than traversing you through a node. That should be clear, right? So now, since we have defined the new solution, what should be the key metrics to track the success of that solution? First is obviously the chat ratings, the satisfaction scores, basically we call it, right? I can very well A/B test this new system using the CSAT or customer satisfaction scores with the previous system. Second most key metric that we should track is containment percentage. What I mean by containment is that how many percentage of chats is this AI solution or the bot able to contain without actually requiring to escalate it to a human support executive, right? For example, if the containment rate is, let's say, 75%, that means that out of 100 chats, 75 chats were handled by the bot itself, and rest 25 chats were escalated to the human. Third is cost efficiency. Now, in the previous system, since it was just a tree, it just had a cost of infrastructure in the tech perspective. Plus, it had some cost of escalating the chats to human agents. As you saw in the first screenshot, that after typing "Where is my order?" The chat got escalated, right? That is the overall aggregate cost of the previous system. But how do we define the cost of new system? It will be the cost of running the AI, because it has some cost, it is not zero, as we all know, and the additional cost of escalating. So to basically make my solution more cost efficient, I need to increase containment percentage so that it is able to offset my the cost increase done by AI. Am I clear here? Right. And lastly, response time. I want to be able to resolve, it is pretty obvious, I want to be able to resolve a concern quickly. You have come to support, you are aggravated, we understand that. We want to reply to you in sub 10 seconds, let's say, right? So that is also a key metric here. So with that, let's deep dive into the solution design of this. How did we actually move on to designing it? So what is the first key prompt or AI agent that comes into mind when you think about generating a response given the customer messages and some order data, right? So the first and foremost component here is that you need a response generator AI agent or a prompt, which runs on an LLM, right? So what all do you need to pass to that response generator? You need to pass some context. You need to pass some linguistic guidelines. So what linguistic guidelines could be that, oh, Zia is the name of the support executive, that the AI agent that we have designed. Linguistic guidelines could say something like, oh, you need to be respectful, the customer is aggregated. Some business guidelines that you do not have to go on and offer coupons without, company policies being met, obviously, right? Some order data. So since we're talking the pre-delivery scope here, what I mean by order data is that where exactly your order is at a given point of time. For example, it could be picked up by the delivery partner. It could be on the way. It could be still be preparing, and it could be that the rider is not assigned yet due to some reasons. So that is the order data. And the other one is ongoing chat. You obviously need to capture the 10 or 12 ongoing messages in the history to carry on the context that what the customer is asking and what is the intent behind asking that. And lastly, response formatting. So I'll be using this construct of functions to denote every prompt. So here you can see that response generator is essentially a function of business guidelines, order data, and ongoing chat. Rest are all static stuff. Context, linguistic guidelines are assumed to be static here. So response is a function of these three variables. Now let's double down on order data. So order data at a given point of time could contain such a variety of data ranging from where your order is to what is the name of the delivery partner and his contact number, to what is the restaurant partner's contact number, etc. So you do not want to always pass the entire data. So since we can use LLMs to capture intent very well, so you do not want to always pass the entire data to generate every message basically. So if I have done 10 messages and I have asked this AI agent that what is their delivery partner's contact number, I do not want to pass the order state into the response generated prompt. So I want to basically filter it. This idea is clear, right? How can we filter it? How did we do at Zomato? We designed a function classification prompt. So this idea, I think people are quite familiar with this. We did it before OpenAI introduced function calling. And so as you can see, some of the functions, get order details, get order status. So what get order status will fetch you, for example, it will fetch you an API response regarding what is the ETA, is there any delay, or what is the current state of the order, etc. So 10, 12 such variables, right? And the ongoing chat. So this function classifier prompt essentially is a function of ongoing chat only, where we assume function calls to be a static element here, right? Next stuff. So for example, get order status API response was, so let's say my function classifier, the customer asked where is my order, and my function classifier decided that I need to trigger get order status in order to answer this query effectively, right? So once I trigger that API, I'll get some JSON response. Now that JSON response is not very digestible by the LLM, right? I need to make a story out of it to convey it effectively to the LLM. So we have designed a very sophisticated transformation layer of JSON to text, which essentially transforms this API response to a corresponding text. As you can go through this example, that the order is on the way, ETA is 12 minutes, there is no delay, and I've designed this corresponding text to be order has been picked up, blah, 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 right? This is very easily digestible by the LLM, can understand very well. So this is the kind of text that goes in. So as you can now imagine that I had 10, 15 functions in the classifier, totaling to, let's say, 10, 15 keys per response. So that is a lot of order data. I do not want to pass it in every go, right? Next. Next variable that goes into this function of response generator. So essentially we're going bottoms up, right? So we are designing response generator here, and then we're effectively moving up how we are inputting those variables that we have designed here. So business guidelines could look something like, as I mentioned, you do not have to offer coupons or freebies without, so the bot can very well hallucinate. So it is very easy to fool AI, right? You can very well go into the chat and say that my order is delayed, and the AI will eventually believe, just like 2 plus 2 equals to 5, it can eventually believe that, yeah, the order is actually delayed, and can maybe hallucinate and tell you that I'm sending some coupons on your way. whereas there are no coupons existing, right? So we want to pass some strict business guidelines here. But again, the number of those business guidelines could exceed 60, 70. But again, you do not want to pass all of them in a single go. It is also contextual. It is also dependent on the ongoing chat that the customer is doing. If I'm not asking for a coupon, then very well, that guideline does not need to be passed here, right? It is essentially just to optimize the number of tokens that go inside response generator being the key component of this solution, plus to enhance the steerability. I do not want to pass 50 guidelines because I do not want to confuse also, right? I just want to pass, let's say, 5, 6 at a time. That these are the guidelines, just follow them and generate a response, abiding by these. So now we have a guideline filter prompt or agent running behind the scenes for this. You can go through these guidelines. So this is an exhaustive list of 60, 70 guidelines that go inside, and along with the ongoing chat, and relevant guidelines are picked up to be passed in the response generator. So business guidelines is essentially a function of ongoing chat only. Let's bring it all together and complete the response generation solution here. So you can quickly take a moment and go through this, that the function classification and JSON to text agents run in parallel with the guidelines filter, prepare some variables for the response generator, and finally all those variables are aggregated at the generator level and response is produced. Right. But in the starting slides, we also mentioned that the requirement of a solution is also to take some actions, right? Where is that? Let's take some actions. So what are some examples of the actions? You must be quite aware, right? That send cooking instructions to the restaurant, modify delivery location, cancel the order, or probably take some system actions like resolve the chat or escalate to support executive. So these are some of the actions I want to encode in this system, that it is not always essential to generate a response. The bot should also be aware when to take some action, because just doing a RAG and answering questions is pretty outdated now, right? So what is the fundamental technique again, thinking from the first principles only, what is the fundamental technique that comes into mind when you want the bot to take some actions? You want a system that takes in ongoing chat. You want a system that also takes order data to see, to see where the order is currently. And you also obviously want to pass in the action classes that you want the bot to take and the conditions along with it. So it essentially becomes a multi-class classification problem, right? So this is the action classifier agent that we have designed, which takes in action classes and their conditions, order data, ongoing chat. So it is essentially a function of order data and ongoing chat, as you can see down below, right? But practically speaking, this does not work out quite well. This approach does not scale very well, simply because we have 8 to 9 actions with a lot of complex conditions. So for every action, let's say we have 10 to 12 conditions, which are probably also overlapping among other actions. So it is not very easy to take those actions. Plus, we are designing a solution that responds in about 10 to 15 seconds. So we cannot use the world's best LLM to do all our stuff, right? We need to optimize for that as well. So what do we do here? There are too many classes and the conditions are complex. We just introduce a verification layer. Now, what is the verification layer? It runs after the classifier prompt, and this always has 2 classes. So we have simplified the problem here to a binary classification only. Right, we did a multi-class classification above, and the verifier layer just does a binary classification. So for example, if my action classifier says that I need to cancel the order, but probably the customer has not mentioned that, right? So the action verifier will take only 2 classes, the conditions for cancel and the conditions for conversing ahead. So it is essentially a sanity layer that checks that, oh, do I need to talk ahead? Can I probably tell the customer that it's on the way and please accept it? It'll just take 2 minutes. Why do you want to cancel it? So this verification layer does kind of that stuff. So the final action is now a function of the action decided by the classifier and order data and ongoing chat. Stitching it again together, we get the action decisioning system here. Moving on, let's bring it all together. And this is the entire system design of producing conversational responses that carry the context and also take some smart actions wherever needed. So as you can see, this response generation pipeline runs in parallel to the action decisioning pipeline. And whenever there needs to be triggered an action, the action decisioning pipeline sends an event to the response pipeline that, stop, bro, I need to take some actions. It takes some actions and gets out of the loop. Otherwise, it conveys to the generator that please go on with conversing. So this is the key idea here. Now, this is overall a broad design of the solution, but as we scaled, since Zomato has a huge scale, so there are a lot of different problems that we encounter that we cannot imagine beforehand, right? So for example, actions like escalating to a support executive are very business critical, in the sense that if you leave it all to the LLM, it can probably give you a containment rate of 80% on one day and probably 50% on the second day. So you cannot really scale the human infrastructure behind the scenes in that manner, right? So you want to introduce some kind of guardrails behind. You cannot leave all the key decisions to the LLM. Also, on a side note, we do not cancel the order through an LLM. We just trigger the action, and that action essentially means that you get a pop-up and there's a final confirmation taken from you. The LLM does not get to take such actions on your behalf. It just triggers some other flow, right? So, yeah, coming back. So how do we solve for introducing guardrails on, some critical actions like escalate? So the key idea here is that in my previous system, since it was just data-driven and did not have very deep intent understanding, so I had complete control in the previous system to which kind of customers or what kind of orders, based on some system variables, I want to allow escalation of a chat, correct? But in this case, what I've done is I've completely relied on the user intent. If the user tries to fool the LLM that my order is delayed, please escalate, the LLM will most probably get scared and escalate the chat, right? So what I want to do here is that I want to kind of find a middle path between both the solutions. I want to capture user intent while keeping in mind some policy variables as well. I do not want to be a fool. So what is the proposed change here? We introduce guardrails by adding another verification layer on top of the decision system that we discussed earlier. That also captures some policy variables along with user intent and order data, correct? Let's go through an example to understand this better. So the key idea here is that LLMs are very good linguistic variable decoders. What I mean by that is that they can understand your intent very well. That was lacking in the previous system, right? So what we have done is that we have married those linguistic variables to our system variables to generate a new function here, to get more data basically. So for example, if the LLM is given escalate, I have now modified those agents to also give me the reason bucket behind why to escalate, right? So for example, a reason bucket that the LLM the action decision system could give me that I want to escalate. And why I want to escalate is because the customer is probably mentioning that the delivery partner is not moving on the map. So DP movement issue is the tagged bucket here. So once I have this tagged bucket, I can very well apply some logics in my system to do a sanity check that whether the delivery partner was moving or not, correct? I can finally make a decision or whether to escalate or not. Second example, escalate and request escalation. So we saw a lot of chats in which the customers try to game the system by saying, oh, escalate the chat. And they figured out that in some ways they got a human executive, right? So again, we designed something for it that if the bucket name is request escalation, we do not deny you escalation. We simply check the notoriety of the user and all the order lifecycle variables of the order. So let's say if the order is not delayed at all, and the user is simply being notorious here. So we can do some sanity there, and we control the escalation part there. So this is the policy layer that we implemented ahead of the decisioning system. So it's a marriage of LLMs and codified variables, determinism and non-determinism. Apart from that, obviously, scale requires some optimizations for you to do because of latency and cost factors. You cannot keep bumping them up. So one glaring optimization that we saw was that you must have seen this snippet that you guys see here. I want to cancel my order. I have a promo-related query, etc., etc. So the key insight here is that always the AI chat starts when you click one of these options, right? So when you click one of these options, you already know what the ongoing chat is kind of in that session. That is the entry point of the chat, right? So it is kind of deterministic there. So we can cut all the variables, ongoing chat. It becomes a constant essentially. So you do not need to run any of the other agents. You simply need to run a response generator. And that too, you know that the customer is just asking, where is my order? Or I want to cancel my order. I can simply run an inferior LLM with few short prompting here. So that's a key optimization that helped us reduce first response latency at scale. Apart from this, we obviously did some other scale. We realized very early in our journey that latency of an LLM, so since an LLM is an auto-regressive model, the latency of every token depends on the number of output tokens you expect. It varies linearly, and we also did an experiment, so it was clear that it varies linearly with the number of output tokens you want. So from the day one, we designed our agents in such a way that the number of tokens that we produce are very minimal, right? So the architecture also of function classification and guidelines filter was designed keeping this only in mind, that the number of tokens is minimized to minimize cost and latency and also enhance scalability. Second is prompt iteration and fine tuning. We definitely tried some fine tuning LLM experiments, but we realized again in very early part of journey while we were scaling that prompt iteration is pretty quick, right? You want to get into fine tuning only when your product is closed, it is final, it is stable, you are not introducing much stuff very quickly. So we introduced a lot of features in this bot, we enhanced a lot of its capabilities while we scaled only due to quick prompt iterations, right? I want to introduce a new action, go on and mention in the prompt that there's a new action and its conditions. The system solution is designed, you just plug in variables now at this moment, right? So this becomes very easy. The life cycle gets quickened. Thirdly, obviously we use mixture of LLMs. We cannot generate response in sub 10 seconds by using GPT-4o in all the prompts, right? Moving on. Yeah. So with Zomato scale, it becomes kind of a necessary evil to introduce evaluation mechanisms. So we use pretty standard mechanism, evaluation mechanism here of human in the loop, where every change, whether it be a prompt change or any other feature change, goes through rigorous human quality checking, and all the chats that happen at daily interval, some sample of it is always QC'd by a human, and all the metrics get published. Apart from it, to solve eval at scale, we also used AI as a judge principle, which is a fairly common principle, which is based on verification is easier than generation, right? So you can ask an LLM to grade a response, it will do much better than generating that response, the same LLM, right? So we designed some key metrics for this solution that we wanted to evaluate using AI. So I'll just give one or two examples here. So first is factual consistency of response. So obviously, if you are passing 12-minute CTA in the order data, you want to check that your agent is not conveying 10 minutes, right? So this is basically a metric that captures whether your response is getting hallucinated with respect to the data you've passed. Second is information relevance. For example, if the customer is asking, give me delivery partner's contact number, I do not want to be telling 12-minute CTA, though it is correct, but it is not the correct answer, right? It's not a relevant answer. Third is guideline compliance of the response, and fourth is customer pain point resolution, just to check whether the pain point that the customer came with was resolved or not from a neutral perspective. Right, let's see some numbers. So, surprisingly, we saw a huge bump in our satisfaction scores, which is more than 2x. Our satisfaction scores doubled, literally doubled, and it was the most driving power that we had, that we need to quickly iterate on this solution. The people were literally, it was getting transformed from support to delight in in front of our eyes, right? So the huge bump in satisfaction scores. 75% dip in response times. So we benchmarked response times with the average time taken by a human executive to respond, which is around 30 to 40 seconds. And this has now come down to 10 seconds. It started with 20-25 seconds, but has now come down to 10 seconds with more optimizations introduced by us. Thirdly, shift in containment distribution. While we did not really are able to increase containment percentage as of now, but what we have seen from our data is that there's a huge drastic shift in containment distribution. What I mean by that is the previous system was dumb enough to so it gave us a lot of control in terms of whether we want to escalate or not, for example, right? But that was not, so it could be escalating in where is my order, but it could be not escalating in some certain other concerns, which are more important, right? So that distribution we have seen, though the number of containment percentage has stayed mostly same, which is benchmarked right now, and but the distribution has shifted a lot. We are really only escalating on key concerns and resolving the chat within the bot itself otherwise. We also had the opportunity to unleash this solution at 100% scale on Mother's Day. So days like Mother's Day are very important in Zomato's context, right? It was on Sunday this year, 12th May, and it broke all the all-time highs of previous year. So we usually hit all-time order highs on New Year's, and this time's Mother's Day broke that record also. So we had the opportunity to, we were at 100% scale with this solution at that time, and we had this opportunity to see the numbers on that day, right? So we supported more than 80,000 customers with more than 1,000 peak messages per minute coming into our system. So these are some of the chats for you to uh, look at. So I think these are the chats before Mother's Day, 11th May, Saturday. So we introduced a little subtle thing to remind people to order cake for their mothers. So that is how support becomes delight. Let's quickly talk about ongoing and future enhancements. So everyone mute the chats. I think 25 minutes. I've designed a lot of other material also, but 25 minutes have crossed now. So let's. So one of our key tracks that are ongoing is that we want to optimize for control, cost, and latency. So now we have designed such a system where it is very easy to A/B test and plug in new LLMs with our evaluation pipeline also set up and system setup. We can plug in new LLMs, new agents, and test them out, shadow them out, and replace them very quickly for while optimizing for cost and latency. Also, since this entire solution was based on pre-delivery, we also started using AI with multimodality coming into picture. We also started extending this solutioning in post-delivery delight. So as you can see, post-delivery issues can range from packaging or spillage issue, items missing, etc. Right? So we have started augmenting human support with AI in these cases, and we have seen significant promise in this case. With our customer satisfactions again going over the park, and compliance and cost going down, and compliance or accuracy going way up. So that's it, folks. Thank you.
Any questions?
Hello. So my question is on the observability aspect of the pipeline. So how much did you even observe any difference after using any observability solutions? Did you able to find any drift in the LM responses or something like that?
So as I mentioned that we use different AI-based metrics that I'll go back to the slide for you. These were some of the metrics which helped us, so observability you were talking about, right? So these four were key metrics that helped us see any drift if possible. Because, so the guidelines compliance of response, the third metric, essentially captures this drift. Because let's say I have asked in 10 different ways to the LLM to respond in a certain linguistic fashion, I can easily capture with this metric if I track it on a daily basis, let's say. So I can see that number, and whenever that number goes beyond a certain threshold, I can very well go and intervene in the system there.
Okay. Yeah, that's.
Thank you.
Hi. Could you talk about your evaluation pipeline?
So, as I mentioned that it is a mix of AI eval and human eval, right? So we have a dedicated team also sitting, which is basically human in the loop, and which constantly check a sample of chats every day, that if anything is going wrong. So we have a lot of system variables, let's say delay buckets, or we have such buckets, a lot of buckets defined, in which we go and check kind of a sample of responses. So that is a human eval part, and the AI eval part, as I mentioned, that we mostly use LLM as judge only on a sample of chats to check for drifts and these metrics basically.
Any recommendation for tools for evaluation?
We use an in-house library, so we do not use any other tooling. We have developed an in-house open source library. Sorry, I mentioned open source. An in-house library that is a toolkit for us to basically fine-tune any LLMs or evaluation. So that essentially pushes some metrics on a centralized dashboard where you can visualize all the metrics on a daily basis. That is a combination of human evaluation metrics and these metrics. So also this last point that I mentioned, customer pain point resolution. So what we also do is that we kind of use AI only to give us feedback for every chat, that where we can improve our entire system, not only the AI solution, but entire system in general. So we also have a weekly digest running for that comes on our Slack channel and tells us that this is a weekly feedback summary of the chats happened over this week. So that is the kind of mechanism that we've developed in-house only. Yeah.
And about the classifiers you mentioned, so you're using a classic ML classifiers or a LLM?
No, since I mentioned that shipping speed was very important here, and AI exactly provides that, enables that only. So we used a mix of LLMs for that, right? But obviously, if we find the need to be, we'll migrate to classical ML models. But for right now, it is the last step that we would do, because we have kind of in this architecture, the key thing is response generator, and it is the rate determining step here basically. Rest of the prompts or agents run pretty quickly. So we'll see if we need to migrate it to a classic ML approach, but otherwise things are fine here.
Thank you.
Yeah, thank you.